Hey everyone. So this is going to be a big series of videos explaining mainly about TCP, the way how TCP works, and what are the things we can do to troubleshoot any issues related to TCP. But before I start with that, so I want to spend some time explaining about the difference between TCP and UDP. So now, so the first major difference between TCP and UDP, well, before I start that, so TCP and UDP, they both are layer 4 protocols used in the communication of data between two devices in the network. So now, the first major difference between TCP and UDP is TCP is connection oriented, whereas UDP is connectionless. So what does it mean? So let's say we have two devices, a device A and device B, and you want to send some data from device A to device B. The way how it works in UDP is the device A will send the data to device B. Done. So it doesn't know whether device B exists or not. It doesn't even know whether the device B is listening to the data or not. And it doesn't even know whether the device B received it or not. So it doesn't care. That's what UDP is. If you want to send some data between device 1 to device B, it will just send it and done. It will close the connection. I mean, connection as such, it will close the transfer. That's how UDP works. Whereas in TCP, before it sends the data from device 1 to device 2, it will first establish a connection. So that is how the TCP starts everything. Like it will always start the transfer with a connection, and the connection, people commonly call it as a three-way handshake, is what will be used to establish the connection. So there will be a SYN sent from the device 1. That's like a synchronized message. So the SYN will be sent to device 1 to device 2. And when the device 2 receives the SYN, it will check whether it's listening on that particular port number or not. I'll explain more about this port number and all in the next video when we start the TCP process. So for now, all you have to know is, okay, there's something called port number in UDP or in both TCP both. And TCP first, the client or the sender will check whether the receiver is listening to that port number or not. That's the whole purpose of sending the SYN. And once the SYN reaches the device 2 or the receiver, in case if it is listening on that particular port number, he will send a SYNAC back to the sender or the device 1. Now, once the sender receives the SYNAC from device 2 or the receiver, he will do a final ACK to confirm, okay, he received the SYNAC from the receiver or device 2. So that is how the connection gets established in TCP. So in TCP, everything will start only after the connection establishment. In case if the connection is not even established, there will be no data transfer at all. So that's the major difference between TCP and UDP. The first difference is connection oriented, right? And how the connection is established, it's through the three-way handshake. And in UDP, there is no such connection mechanism, and there is no three-way handshake or anything. So that's the first difference. Moving on, the second difference is TCP is a reliable protocol, whereas UDP is unreliable. So what do I mean by reliable and unreliable? So let's say you have 10 bytes of data to send from sender to the receiver. In case of UDP, it will transmit all the 10 bytes to the receiver and it's done. It doesn't care whether the receiver received all the 10 bytes or not. Whereas in TCP, we use something called sequence number and ACK number. Again, we'll go through it in the next video. Using the sequence number and ACK number mechanism, TCP makes sure the receiver received all the 10 bytes. Like there is no single loss of byte between the sender and receiver. Like in case of UDP, let's say you are transmitting 10 bytes and 8 bytes reach the receiver, but not the 2 bytes. The sender doesn't care. In fact, the sender doesn't even know that the receiver did not receive the 2 bytes. Whereas in TCP, the receiver will keep tracking the sequence number, the sequence of data it's receiving, like from byte 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And in case if it doesn't receive byte 6, the receiver will inform the sender that hey, I did not receive the byte number 6 or the packet number 6, whatever uh, the sequence number it's using. And now the sender knows that, okay, there is something wrong in the transfer. So it will retransmit the packet byte number 6 to the receiver. So that's how TCP maintains reliability in the data transfer, whereas UDP doesn't have that reliable mechanism. The third uh, point is ordered delivery. So TCP does something called ordered delivery, where so we are talking about layer 4, right, where the transmission is happening, but the data actually is received from the application layer, which is layer 7 on the sender side. So in OSI model, the 7 layers in OSI model, right? So the first top layer is application layer, which is what generates the data and transmits down all the way to layer 4. Let's forget about layer 6 and 5, which are commonly used in the application side itself. So once the data reaches the TCP layer, which is layer 4, and that's when it will start transmitting the data using the sequence number and ACK number. Now, when the receiver receives the data in the layer 4, it will send the data upstream to the application, but when it does it, it will make sure that the data is sent to the application layer in the ordered fashion. Because since, as we discussed earlier, TCP uses something called the sequence number and ACK number. With the help of sequence number, the TCP layer, the layer 4, can track the order of the packets, and once it receives all the packets in the proper order, it will transmit the packet upstream to the layer 7, the application. Whereas in case of UDP, there is no such tracking mechanism. So whatever it receives from the sender, it will just push it to the application. Now it's the application's responsibility to make sure it can reassemble the data in the proper order. Now, the next part is the speed. So TCP is generally considered as a slow transfer mechanism, whereas UDP is the transfer happens pretty fast. Because in TCP, every time you transmit something, we discussed about this sequence and the ACK number, right? So the TCP has to make sure that it receives an ACK for every data it's transmitting. So while waiting for the ACK to be received, that will consume some time in the data transfer, and it will make it a little slow. Whereas in UDP, there is no such ACK or sequence number mechanism, so it will keep on punting the data to the receiver. So that way, it will be pretty fast. So now the next point is the fair transfer mechanism in TCP and greedy transfer mechanism in UDP. So as we discussed again, it's all revolving around the same concept of sequence number and ACK number. So in UDP, since there is no tracking mechanism, like it doesn't care what is the network bandwidth. Like it will try to send the data as fast as it can, the sender, and even if it gets lost in the network, like even if you are transmitting something over a 10 Mbps link, UDP will continue to burst the traffic as fast as it can. Like as much as data it receives from the application layer, it will keep on sending the data in the network. And that's why UDP is commonly used for slow applications. When I say slow applications, the application that transfers data in the slow rate, even though the transfer rate is pretty fast. Like for example, if you have a 1 GB of file to transfer, and if you use UDP, the application can send the whole 1 GB data to the layer 4 UDP process. And once the layer 4 receives the whole 1 GB packet, it will keep on trying to send the traffic over the NIC card, even if the NIC card is like 10 Mbps NIC card. And the packets may eventually get dropped in the network during the transfer. So, but if you think about a VoIP call where the UDP is commonly used, in terms of VoIP, it's mostly like 64 kbps, 64 kilobytes bits per second. That's the rate of the voice call. So in that case, even though it's fast and even though it's greedy transfer means we don't care who is using the network. We don't care what is the network bandwidth. That is, UDP will keep on sending the data. That is what I'm referring here as greedy transfer. Whereas in TCP, it does something called fair transfer. So it's something that happens again based on the sequence number and ACK number mechanism, where so whenever there is a packet drop observed in TCP transfer, the TCP will slow down the transfer. So let's say we are sending 100 bytes and expecting and waiting for an ACK from the receiver. And next time we are sending 200 bytes waiting for an ACK from the receiver. So that's how the TCP will keep on incrementing the rate at which it's sending. And suddenly after like 400 bytes, you see there is no ACK coming back from the receiver. So now what the TCP will do, it will reduce the rate at which it's transmitting, like from 400 to 200 or even 100. So again, we'll discuss about this in the advanced TCP sessions. But for now, whenever there is some packet loss in the network, the TCP has a mechanism to reduce the data transfer, the transfer rate. Whereas in UDP, there is no such reduction happens because it doesn't even know that the packet got lost in the network, right? So that's the next difference, like the fair transfer in TCP versus the greedy transfer in UDP transfer. So where do we use TCP? TCP is commonly used for data transfer. Like you want to send some data from one device to other device. It can be FTP, or it can be file download over internet or browsing the internet. So all sort of things uses TCP, where the reliability is more important than the speed. Like let's say you're browsing something, and let's say you're transmitting a file from one device to other device. The speed is equally important, but more than the speed, you need to make sure the data transfer is complete. You need to make sure that you sent 100 bytes and the exact 100 bytes were received with the receiver. So that is more priority than the rate of the transfer. So that's when we use TCP. Whereas in UDP, we don't care if the packet got lost. So let's say you're talking to somebody on the phone and you're saying, hey, how are you? And that particular R word got lost. So how the receiver will receive it? Hey, how you? So now let's say we use TCP for VoIP. So now the same R will be retransmitted from the receiver, so from the sender. Now, now how does it look like? Hey, how you are? So you see the difference, right? Like, hey, how are you is what it's supposed to be. And if the R got lost, it's going to be like, hey, how you? And in case if the same R gets retransmitted, it's going to be like, hey, how you are. So it won't make sense to retransmit the VoIP or video traffic over the network. And that's the main reason why we use UDP for voice and video. The same kind of example can be applied for video as well. So that's all about the difference between TCP and UDP. So from the next video onwards, we'll focus more on TCP. So I'll start with the TCP headers. What is the use of each TCP header? And then we'll go deeper into various congestion control, congestion avoidance mechanisms in TCP, and how all these things are implemented in TCP. We'll discuss about it. So to recap on a very high level, so TCP and UDP. TCP is connection-oriented protocol, whereas UDP is connection-less protocol. And TCP is reliable, where every data is acknowledged by the receiver, when UDP is unreliable. And when the data is delivered to the application, it will be delivered in the same order sent by the application, by the sender. Whereas in UDP, it's unordered, because if the data gets unordered in the network, it will be delivered unordered to the application. So it's the application's responsibility to reorder it properly. And TCP is slow, mainly because of the ACK and reliability it has. Whereas UDP is pretty fast, since there is no ACK or reliable. There's no ACK, or it doesn't wait for the ACK to be received from the receiver. And TCP, it gives a fair transfer. Like if there are 10 devices in the network, all the 10 devices can make, you can guarantee that all the 10 devices will get a fair data rate. Whereas in UDP, all the 10 devices will try to utilize the full bandwidth and may end up in packet loss. And examples are SMB or FTP for TCP. And for UDP, it's going to be like VoIP and video. Thanks for listening to this video. And next one will go the TCP headers. Thank you.